Good morning. I'm Vijay Madhvi. In the today's session, we'll learn about multiple access protocols. Okay, that means here what is mean by multiple access protocols? Whenever if we have a data transmission, that means when a sender and receiver has a dedicated link to transmit the data packets, then the data link control is enough to handle the channel. Whenever if we have a transmission of data between the sender and receiver, okay, if we have a dedicated link to transmit the data packets, then the data link control is enough to handle the channel. Okay. And next, suppose if there is no dedicated path to communicate, if we have a dedicated path, then it is easy for us for the communication of data. But if we do not have any dedicated path, okay, or for the transmission of data between the two devices, in that case, multiple stations access the channel and simultaneously transmit the data over a channel. Okay. That means we may also have the problem of crosstalk or collision. For example, this here the general example we have. Okay, that means if we have a communication between the client and server with a dedicated link, then we do not have any issue for the transmission of data. Okay, but if the link is not there, if the dedicated path is not there, then we may have multiple access. That means from multiple stations, the channel can simultaneously transmit the data. Okay, that means hence this multiple access protocol is required to reduce the collision and avoid the crosstalk. Okay, that means in a general manner, I'll explain here. Whenever if we have a communication between the client and server or sender and receiver, if we have a dedicated link, then the transmission will be simple. But if there is no dedication link for the communication, if there is no dedicated path, then what we may have the multiple stations for the transmission of data. Okay, and here the multiple access protocol is required to reduce the collision and also to avoid the crosstalk. Okay, for example, suppose there is a classroom full of students. Okay, if a teacher asks a question, all the students, that means we can call all the students as a small channels. Okay, in the class start answering the question at the same time, transferring the data simultaneously. That means all the students respond at the same time, due to which there is an overlap or data loss. That means therefore it is a responsibility of a teacher, that means the multiple access protocol, to manage the students and make them to answer. That means if we get the data, if one of the students are answering, means we can get the data in a proper way. Okay, otherwise we'll not get the data in a proper way. Yeah. It means if we have the multiple access protocol, responsibility is what? That means see here, we can call the responsibility of a teacher is to manage the students and make them to answer one after the other. Okay. And next to see here, like very simply, I can say like there are different types of multiple access protocol. Okay. That means the multiple access protocols are subdivided into different types. For example, majorly these multiple access protocols are divided into three types. One is the random access protocol and controlled access protocol and channelization protocol. Whenever if we have this random access protocol, then we have Aloha, CSME and CSME by CD and CSME by CD. Okay. Then the controlled access protocols are reservation, coding and token pass. Okay. And whenever if we have this channelization protocols, means here we have this frequency division, FDME, TDME, and CDME. Okay. Now we learn about the in-depth explanation of all these things. Okay. And now here, what is meant by this random access protocol? That means in this protocol, all the station has the equal priority to send the data over a channel. Okay, that means see here, some station can some stations can send more data, some station cannot send less data. It is not like that. Okay, that means all the stations has given the same priority. That means in this random access protocol, one or more stations cannot depend on another station, or any station control another station. That means each and every station, it is separate. That means here, depending on the channel state, each station transmit the data frame. However, if more than one station sends the data over a channel, then there may be a collision or data conflict. Okay. And now here, these are the following different methods of random access protocol. These are Aloha, CSMA, CSMA by CD and CSMA by CA. Now in this session, we'll learn about Aloha. Okay. Here, what is mean by this Aloha random access protocol? It is designed for wireless local area network. Okay. That means, but can also be used in a shared medium for the transmission of data. By using this Aloha method, any station can transmit the data across a network simultaneously. Any data frame is available for the transmission. That means here now we are learning about what is meant by Aloha. That means it is designed for wireless local area network, but can also be used in a shared medium. Okay. That means it is mainly used for the transmission of data. Okay. It is mainly used for the transmission of data. Using this method, any station can transmit the data across a network simultaneously when a data frame set is available for the transmission. And what are the rules for the Aloha? That means any station can transmit the data to a channel at any time. Okay. And it does not require any carrier sense. Okay. And collision and data frames may be lost during the transmission of data through multiple stations. Okay. And the acknowledgement of the frames exists in Aloha. Hence, there is no collision detection. Okay. And it requires a retransmission of data after some random of time. That means here, these are the major rules which we have to follow for the Aloha. Okay, that means see here, like whenever if we have this transmission, like any station can transmit the data to a channel at any time. Okay, and here, like whenever if we are having this Aloha means we have two different types of Aloha. One is a pure Aloha, another one is the slotted Aloha. Whenever if we are learning about this pure Aloha, okay, whenever the data is available for sending over a channel at all times, okay, that means here if we have a data is available, okay, over a channel at all stations, then we use the pure Aloha. Okay, in pure Aloha, when each station transmits data to a channel without checking whether the channel is ideal or not. Okay, the chances of collision may occur. Okay, and the data frame can also be lost. Okay, that means here what is mean by this pure Aloha means whenever the data is available for sending over a channel at all stations, then only we use this pure Aloha. Okay, and in this pure Aloha, when each station transmit the data to a channel without checking the channel is idle or not. Okay, and here in this pure Aloha, here it will not check anything, just if the frame, that means the collision also may occur. That means it will not check whether it is empty or not. Here the data is available for all stations without checking whether the channel is idle or not. Here it is going to send one after the other. Okay, that means there is a lot of chances for the collision of frames. Okay, you just see here it is the station 1 is sending the frame at the same time. Station 1 is sending first 1.3, 1.2, 1.1. That means see here, like whenever if it is sending 1.1, 1.13, okay. That means next immediately it is also sending. This frame station 2 also sending. At the same time, station 3 is also sending. Station 4 is, that means this, that means here the station will not wait until the other station sends, because it like automatically one after the other, the data transmission will be done here. Okay, and slotted Aloha means what? Here in this slotted Aloha, this slotted Aloha is mainly designed to overcome the problem of pure Aloha. Okay, that means here the pure Aloha efficiency, because pure Aloha has a very high possibility of frame hitting. Okay, in slotted Aloha, the shared channel is divided into fixed time interval, that is called as a slots. Okay, here those are called as a slots. Okay, here in this, like in slotted Aloha, the shared channel is divided into fixed time intervals. Those are called as the slots. So that if a station wants to send a frame to a shared channel, the frame can only be sent at the beginning of the slot. Okay, and only one frame is allowed to be sent each slot. See here I have, like in the slotted Aloha, this station 1 is sending. First, it has sent one data. Okay, then here this frame 1, one after the other, one after the other. That means here, if I have in slot 3, first if it is sending means in the slot 3, later only it is going to send. One after the other only the transmission will be done here. Okay, and here we'll also learn in the random access control only here, like in this, here in the random access protocol, we have this Aloha, CSMA and CSMA by CD. Okay, here in this, like what is meant by the CSMA? That means what? Carrier access, carrier sense multiple access. Okay, here in this carrier sense multiple access based on media access protocol, it is mainly used to send the traffic on a channel. That means whether whenever if it is transmitting the data, it is going to check whether the like to know the status of the traffic. It means that if the channel is idle, the station can send the data to the channel. Otherwise, it is going to wait until the channel becomes idle. Okay, that means here, whenever if you have the work, whenever if you are working with the CSMA, then the number of collisions will be less, because in this CSMA, carrier sense multiple access, the system, that means here the like whenever if the system, the station is going to wait until the whether it is any station is sending the data. If there is no data is sending, then only it is going to send. Okay, and here in this we have three different modes. Different modes are there. In this, the first one is one persistent. What is meant by this one persistent mode of CSMA? That defines each node first sends the shared channel, and if the channel is ID, then only it is going to send the data. Else it is going to wait to keep track of the status of the channel to be idle and broadcast the frame unconditionally as soon as the channel is idle. Okay, what is meant by this one persistent mode of CSMA? It defines each node first sends the shared channel, and if the channel is idle, then it is going to immediately it is going to censor it. Okay, and next, what is meant by non-persistent? It is access mode of CSMA that defines before transmitting the data, each node must sense the channel, and if the channel is inactive, then only it is going to immediately send the data. Otherwise, the station is going to wait for the random time. Okay, and when the channel is found to be idle, then only it is going to transmit the frames. Okay, and next, what is mean by P persistent? It is a combination of both. It is a combination of both one persistent as well as non-persistent. Okay, and here in this, the P persistent mode defines that each node senses the channel. Each node senses the channel. Okay, and if the channel is inactive, then only it is going to send. It is going to send a frame to a P priority. If the data is not transmitted, it is going to wait. Okay, then the random time and resumes a frame with the next time slot. Okay, and what is mean by this O persistent? It is an O persistent method that defines the superiority of the station before the transmission of the frame of the shared channel. If it is found that the channel is inactive, the each station is going to wait for its turn to retransmit the data. Okay, and in the next here, this is one persistent, non-persistent, and P persistent. In one persistent, directly it is going to send, and non-persistent it is going to wait. And in CP persistent it is a combination of both one persistent and non-persistent. Okay, and in the next session we'll continue with the same concept. See you in the next class.